So first off, thank you for having me. Long trip, and I appreciate you having me. Thank goodness for the coffee because I had some barbecue earlier. I have to keep up through the presentation. But what we'll be talking about here is extended coverage sprinklers. We'll also debunk a few myths about sprinklers. If I'm speaking too fast, throw something at me and I'll slow down, okay? So then we'll start to move into window sprinklers. Pretty sure you got a good background on me. One thing that I want to mention is I work at the Research and Development Center developing sprinklers and valves for Tyco in Cranston, Rhode Island. So we concentrate a lot on training, whether it be design or for inspection and testing and maintenance. But I studied at Oklahoma State University, fire protection and safety engineering, and I'm still studying. So what we're going to do here is identify the key concepts on sprinklers. We're going to talk further into extended coverage sprinklers because there's a lot of misunderstandings, and then also how to utilize special application sprinklers. Similar to what we spoke about earlier about the performance-based design and things that are outside the standard practices. So one of the big things in the fire protection industry is the understanding of sprinklers, and Hollywood doesn't do a good job for us. If you see the movies, somebody shoots a sprinkler and then all of them activate. It's not how it works. They're all individually operating sprinklers. So if a fire was to start here and I had a sprinkler above me, this one would operate, but the ones further would not. Now we do have different deluge style systems with open nozzles for special hazards and special protections, but your traditional sprinkler system doesn't work that way. Even to this day, there's a lot of commercials out there that don't do any justice for us. So another thing to mention here is active systems versus passive systems. So our passive fire protection systems are typically construction, your fire-rated corridors, and what they're made to do is isolate that fire in a specific area and make it so it doesn't grow further. When we talk about our active fire protection systems, we're talking about our sprinklers. When they operate due to heat, we use that water to actually control or suppress the fire, to make that fire smaller or more manageable for the fire department to come and put the fire out. So we're going to concentrate heavily on active fire protection systems here. So just a quick introduction to sprinklers. We have three standard installation types. You have an upright sprinkler, which is on the left, very obvious here. You have an umbrella-shaped deflector. Water flows up, hits the deflector, down it goes towards our hazard. The pendant on the bottom side of the pipe, and then we have a sidewall, which we'll talk about further as well. The sidewall is typically what you see in your hotels and office buildings. What that allows for is for easy installation. If you have a common chase and you have a repeating floor plan, I can just run one pipe up that common chase and into that hazard area with the sprinklers, rather than run sprinklers up and over the hazard. So what I have here is a fusible link sprinkler. So how this one activates is there's two pieces of metal and they're soldered together. At a certain temperature, that solder will melt and those two pieces of metal will separate. Go back one slide. You also notice that there's glass bulb style sprinklers, and how they work is inside, the liquid inside expands at a certain temperature. There's also an air bubble inside there. So when it heats up and it expands, that glass breaks due to the pressure. Very similar individually operating sprinklers, but here's a fusible link sprinkler operation. The slow motion video. Videos are a lot better than listening to me the whole time, so there's going to be a few videos in here. So another misunderstood sprinkler in the industry is the concealed sprinkler, and you'll see this concealed sprinkler all over the place. The benefit of this sprinkler is for aesthetics. A lot of architects, a lot of people don't like the looks of sprinklers. I disagree, but not many people have my beliefs. So what we do is we offer the concealed sprinkler. I'll have a video to show operation, but you'll notice that there's a small gap here, and that cover plate is soldered on at a lower temperature than that of our sprinkler operation. So as the fire grows, this white plate here will fall off, exposing the sprinkler, As the fire continues to grow, the heat will release the operation mechanism, and it will operate the sprinkler. Here's a video of operation of the concealed sprinkler. Again, this is for aesthetics. I feel bad for the person lighting the fire here. You'll see why in a second. You notice that our cover plate's rating is lower than that of our sprinkler itself. That way it falls away in the fire scenario. Now you see why I feel bad. They're the torch, and now they're getting wet. But it's a misunderstanding all over the place on how this works. A really good representation here. So why are sprinklers important? If you start to study sprinklers and look at the benefit of sprinklers, our concentration when designing sprinklers is property protection. And I know it's kind of counterintuitive, but if we're able to keep the structure up, we lose less property, but ultimately people can get out of that structure. So it also saves lives. So property damage, property cost during a fire event, and life safety. So one thing in Rhode Island that kind of hits home to us is the Station nightclub fire, and very similar to your MGM fire. If you've been in the industry at all, you've kind of heard of this. In Rhode Island, there was a nightclub, and during a concert, a rock concert, they used pyrotechnics, fireworks, and whatnot. Throughout that facility, there was soundproofing. So it was combustible soundproofing, and what you're going to notice is there was a flame spread through the area. There were some egress issues as well, but the fire got out of control very quickly. After the fire, TYCO and NIST, so the National Institute of Standards and Technology, did a series of studies. They initially started fire modeling to see this fire growth. And then what they did was install sprinklers, so you could see the difference between a non-sprinklered facility, of which it was, and a sprinklered facility if it was to be sprinklered. I say this kind of touch home because I'm from Rhode Island. If you live there, you kind of know somebody who was affected by this fire. But we ultimately lost 100 lives that day, and we also injured over 200 people. So what you're going to see here is a video and a mock-up of this fire inside of a nightclub-like area. In the back portion, the black mat there would be combustible soundproofing. When you look at the standard and the classification of this hazard, it's a fairly low classification, most likely around an ordinary hazard classification, so this is not uncommon to see. But you can see this rapid flame growth already. And if you think about a concert, one of the issues, and we talked about the psychology through egress earlier, is you kind of might think that this is a part of the concert. So that's kind of takes effect to get out as well. So kind of interesting. This is around 11 o'clock at night. Think about any concert. Typically there's some drinks involved and everyone's having a good time, and that also affects trying to get out of this area. So one thing you take a look at very quickly is that smoke level. Started at the ceiling, very rapidly grew towards the floor itself. This changed our life safety code in Rhode Island drastically. What you'll notice now in our new areas is you'll see exit lights down at the base of the floor, because that's typically where you're trying to crawl out. But to take it a step further, we installed sprinklers to see what sprinklers would do to the very same scenario. You can see our pendant sprinklers installed here. Our activation of our sprinklers. Notice again that not all of them operated. We still have a couple here that did not operate. So it's pretty obvious on this video, and we're not as far into this video, that survivability and property damage by far would be reduced with the installation of sprinklers. So it's a pretty eye-opening, even though it's a sensitive subject, pretty eye-opening comparison from sprinkler to non-sprinkler. So how do sprinklers work? That's a kind of interesting topic, because if you've been in the industry for a while, you've noticed that the triangle kind of moved away, and it's a tetrahedron. There's a chemical chain reaction. But sprinklers concentrate on the basis of the fire triangle, being heat, fuel, and oxygen. If you remove any one of those legs, you cannot sustain fire. So what sprinklers do is they cool. So with water, it takes a lot of heat, a lot of energy out of the fire and reduces that heat, inherently knocking the heat leg out of the fire. So that's how we achieve control with sprinklers. From here, we're going to move into standard coverage versus extended coverage. So we kind of hit our introduction to sprinklers. Now we're moving on to standard spray and extended coverage sprinklers. So one of the misconceptions is how an extended coverage sprinkler works. And this is a really good visual in comparison of the different types. So with our most common being a standard spray sprinkler, what you'll notice is as I increase the pressure, I increase the density or the amount of water downwards. The coverage area, so if it's a 10 by 10 coverage area, it doesn't change drastically, just more water goes downwards. And that's what you'll see here. As that darkens up, more water goes down as you increase your pressure. With an extended coverage sprinkler, it's a little bit different. As I increase pressure to an extended coverage sprinkler, the coverage area changes. All right, so rather than be a 10 by 10 area, it'd be, as you increase pressure, it'd go to a 12 by 12 area. But the amount of water downwards remains the same. So you'll see a lot of them are listed at ordinary hazard or light hazard, and you can't use them for multiple hazard classifications like you can a standard spray sprinkler. So what you'll see here is another visual. Well, it went kind of quick. That went really quick. That's not how quick it happens, all right? But as you can see, our coverage area at the base here is widened, but the density itself remains the same through each stage just by increasing pressure. So what this allows us to do is have design flexibility. So a place where only one standard coverage sprinkler could cover, or two standard coverage sprinklers, maybe I can eliminate one of those sprinklers and put an extended coverage sprinkler and get an equivalent or better fire protection scheme. So you'll notice here is a good spray pattern. This here is going to be our sprinkler on the corner of the graph here. But the top one, if I increase the pressure from 0.48 bar to 2.07 bar, that coverage area doesn't change, but our flow increases, okay? More water downwards. With extended coverage, pressure changes and that coverage area changes. So pretty useful tool. You'll notice with our extended coverage spray profiles, it's a flatter spray pattern. So one thing that it does is it kind of widens out, which means obstructions could be a little more difficult to get water around things that are either hanging or conduit that's running through that facility. And that's what, as you use an extended coverage sprinkler, this is how it achieves. It just kind of lifts the spray pattern up a little bit so it can achieve that extended coverage. So this is a common myth. Let's say our extended coverage sprinkler, we need to protect a 6.1 meter area. This circle represents what people typically think extended coverage sprinkler would cover, when in fact what it does is it ensures that that density is over the entire area, so that it's actually an expanded throw or expanded spray pattern than what's commonly believed. So what can I use an extended coverage sprinkler for? You think of the hazards that you have, you can utilize it for the most part. So your light hazard occupancies, things like office buildings, all the way to your ordinary places like parking garages and things like that, through your extra hazard processing plants and such, and all the way into storage. And people tend to forget to utilize them for storage as well. So very versatile sprinkler, just very misunderstood. That's why it's not applied commonly. NFPA 13 being the installation standard for water-based fire protection sprinklers lines out how you would utilize their design areas. A lot of manufacturers like us also try to capture niche markets, and we'll do our own testing. So you follow our manufacturer's guidelines. They'll walk you right through that as well. Technical data sheets can be your best friend when designing for these. But one of the big things that we tend to not think about during sprinkler design is our customer's pocket, right? Our sprinklers are fairly expensive. Our sprinkler systems are very, very expensive. But if we can decrease the cost of installation, and one thing that we don't worry about in the US, but you may worry about in Brazil, things I don't even tend to think about is things like painting the sprinkler pipe. That takes a lot of money and a lot of time. If I can decrease that by utilizing an extended coverage sprinkler and decrease the amount of branch lines and cross mains, ultimately our customer gets a better protection scheme, and it's also better for their pocket. So what you're seeing here is a sprinkler design. Both you're going to see standard sprinklers and you'll see extended coverage sprinklers. So a very good benefit here for repeating floor plans is utilizing that sidewall sprinkler. So you'll see here, this is a hotel area. The rooms themselves are 5 meter by 10 meter. 4 rooms, 9 meters by 10 meters. Very common layout, repeating floor plan all the way up. So what the standard density area method tells you is if you have a hazard, you need this density downwards. All right, so what we would classify this occupancy as is an ordinary hazard occupancy. Here, how you utilize these charts, and this is per NFPA 13, is you have your density here, or here at this point, at this area. So the most remote area, the hardest place for us to get water, requires this density. So ordinary density, 6.1 millimeters per minute here, over 139 square meter remote area. So with our standard coverage sprinklers, utilizing a K5.6 sprinkler, fairly small orifice style sprinkler, and we also will compare utilizing an extended coverage 11.2 K factor or larger orifice sprinkler. So with the larger orifice sprinkler, you will get more water out, but if I design for less heads, it should equate. So on the left, you see a standard coverage sprinkler protection scheme. What you're noticing here, the utilization of sidewalls. I have 3 sidewalls in the room. I also have a pendant or an upright, depending, most likely a pendant, here in the little corridor area. Well, with extended coverage sprinklers, I don't need all these sprinklers inside the room itself. Or in this, you'll still need coverage in the corridor area, but you'll notice that one sidewall sprinkler, by increasing that pressure, will cover and protect this area at an ordinary hazard rate. So it's pretty self-explanatory here. Same exact layout, one utilizing NFPA 13 for standard spray sprinkler design, and one with extended coverage sprinklers. I can eliminate up to 3 sprinklers and 2 branch lines, a decent amount of pipe, just by utilizing the extended coverage design scheme. So we ran it through our hydraulic calculation formula, and what you'll see here is our standard coverage, calculated area, flow, and pressure. So calculated pressure, 9.19 bar. Calculated flow, 1301.9 liters per minute. And that's our standard coverage sprinkler. So you can see the same pipe layout that we just showed on that last floor plan. Now as you move into extended coverage sprinklers, you have 1122 liters per minute at 9.8 bar. So relatively similar flows and pressures, but a lot less pipe, a lot less sprinklers. Again, ultimately better for your customer as well. So this portrays into the design, pipe size, cost, labor, and that's what we're comparing here. So sprinkler spacing of our extended coverage sprinkler, 5.4 meters. Standard spray sprinkler, 3.6 meters. And if you notice here, we have a lot less pipe for our extended coverage sprinkler. A lot less pipe, a lot less fittings, a lot less heads. And then this is a cost comparison, and forgive me, again, I'm not used to doing fire protection work in Brazil. So the painting wasn't added in here. So go ahead and put that in there, all right? But you see our cost difference here, value difference of $5,000. For 20 floors, that's over $100,000 difference. That's huge, especially in urban environments where we're building up. And you start to look at a lot larger, a lot taller buildings. That's a huge cost saving. Labor as well as material. So incomplete 24% cost savings in the entire system just by taking a standard spray sprinkler layout for a repeating floor plan in a hotel and changing it to extended coverage. So this is not a sales pitch, but I'm going to push a couple of these technical data sheets just to show you things to look out for. I know it's probably small font, but what you're noticing here is a minimum operating pressure of 7 psi. Now this is a unique sprinkler. When you get into NFPA standards, you can actually utilize this sprinkler for large box storage areas and for storage facilities. So one thing to point out is a minimum pressure of 0.48 bar. When you start to think about tall storage facilities, 0.48 bar is a very minimal pressure. So to be able to utilize that to your advantage, especially where municipal water supply is not the most reliable, is very beneficial. So these things come, our extended coverage sprinklers, any type, size, shape that you want. Very similar to what you see for standard coverage sprinklers. Again, another thing to point out here is the 4.3 meter by 4.3 meter spacing. So very similar to what you're used to in looks and aesthetics, but you can achieve a larger design area. All right, they can become recessed. That's another aesthetically pleasing sprinkler. It just allows it to fit further into the ceiling tile. But again, you're noticing 6.1 meter by 6.1 meter coverage area. That's a very large area when we start talking about sprinklers. So pretty impressive. All different flavors. The colors are not flavors, like a lot of candies and things like that, but all different shapes and sizes. To go further into our sidewalls as well, when you start talking about your hotel rooms or office buildings, there are sidewalls. What you'll notice here is you can get a 4.9 meter by 7.3 meter coverage area with the sidewalls. So it's not a true square pattern, more rectangular, but it's a good protection scheme. Very same coverage area there as well. So as you see here, this is the SW20 and 24. You start to get to a 4.9 meter wide by 7.3 meter throw for a sidewall sprinkler. That's pretty impressive. I'm sorry, I keep looking back. I'm trying to convert from feet to meters. It's not the easiest for me. I apologize for that, but that's why I'm looking backwards here. So again, 4.9 meters by 7.3 meters. And then we also have options in concealed pendants. One thing that we don't think about is the psychological means of sprinklers, especially in hotel rooms. A lot of big issues that we have is somebody hanging, I don't know, a nice white dress or something like that on one of the sprinklers, on one of the sidewalls in these hotel rooms. They don't understand that typically sprinkler water is disgusting to begin with, very gross, very dirty, but if you can eliminate that visual of the sprinkler and being able to hang it on there and utilize a concealed sprinkler, it's a lot better of an option. So again, you're seeing the cover plate. This is a good picture of what happens here, our fusible elements in the center there. So as the fire grows, the heat goes through that gap, which preheats our element, gets it ready to start during a fire scenario. This cover plate would fall away, operate our sprinkler, and get water ultimately to our hazard. So 37.2 square meter coverage area. Pretty impressive. These concealed sprinklers come in all different shapes and sizes as well. So you'll also notice that it tells you exactly what you could utilize it for in the bottom line here. For dormitories, hotels, reception areas, office buildings, banquet facilities, you name it, whether light or ordinary hazard, you could utilize it. So another thing you can utilize them for is MRI rooms. We have a non-metallic sprinkler for those areas for very expensive medical equipment. Then we'll start talking a little bit about our dry pendants. And what this allows for is for colder environments, which I know is kind of a joke here in Brazil. It's been kind of warm the entire time. But if you think about cold storage areas and loading docks where you might get that cool airflow, this allows you to utilize a dry barrel sprinkler, so one with no water in it, and it threads into our wet pipe system to allow for protection scheme. So we also have extended coverage dry barrel sprinklers as well. And dry barrel concealed. So plenty of options. Again, when you start to look at the standard, I kind of challenge you to take a look at the standard practice, utilizing standard spray sprinklers, and compare it to the extended coverage, because a lot of times those chapters never get opened because we find one solution and kind of stick with it because that's what we're used to. Those dry barrel sidewalls, a lot of times those are good for cold areas of, I don't know, carports and things like that as well. So we're going to move, kind of switch gears into window sprinklers. Hope that gave you a pretty good overview of extended coverage sprinklers, or at least a little bit of information. That way you can research more and see what application fits your needs. But we're going to move into something a little bit different, and that's the window sprinkler. What this allows for is a 2-hour equivalent rating. When I say rating, I'm talking about a fire-resistant rating. So here in Brazil, my understanding is your external facade has to be fire-rated. This would not be a good option for that. But interior, where you have exit corridors or egress corridors that need to be fire-rated, utilizing an active means, being a sprinkler, you can get an equivalent 2-hour rated. So another thing that we don't think about typically is our customers' pockets, right? So when we start to talk about fire-rated glazing, word is that it's typically $90 per square foot. Sorry again for the conversions, all right? But very expensive per square meter. And it's a lot heavier. So that translates in structural means as well. You have to use the structure to support the glazing units. So if we could utilize a sprinkler, and that was the concept behind this, to achieve a fire-resistant rating, it would be a lot more cost-effective. But this is a special application approach, or a performance-based design approach. So if you open up NFPA 13 or any of your building codes, you're not necessarily going to see the requirements and standard installation practices for this window sprinkler. Us as a manufacturer can utilize what we call the new technology clause inside of these code books to achieve an equivalent or better protection scheme, utilizing tests and research to back our design plans. So this would be an alternative means if you use it in the proper orientation for your fire partitions, fire breaks, and those are typically your passive systems, okay? So you have multiple temperature ratings here, but the equivalency is for a 2-hour rated. So if you need a 4-hour rating in that corridor, this is not a solution for all fire ratings. So one common misunderstanding that most jurisdictions have is the utilization of sprinklers for glazing units themselves. I've been to plenty of cities where you go either into an atrium or you go into the hotel rooms, and somebody has approved a standard sprinkler right next to the window as what they call a water curtain, which is a very misunderstood term in the fire sprinkler industry. So our primary goal here is to utilize this sprinkler and put a clean sheet of water over the entire glazing. And what that does is it decreases the penetration of the radiant heat. Okay, so as that radiant heat spreads, very hot fire, cool glazing, it starts to hit the glazing up, then fire department comes in, fire service comes in, and they put very cold water on that glazing. So if we don't have a clean sheet of water, we get what they call thermal shock, and that glazing unit breaks, which inherently defeats the whole purpose of a fire-rated glazing unit. So that's the whole concept behind this window sprinkler. This is a pretty good visual to show the difference between your standard spray pattern and your window sprinkler spray pattern. This misunderstood water curtain from your standard spray sprinkler has an umbrella-shaped spray pattern, which is going to leave these gaps, which allows for that thermal shock that we spoke about. So what we're shooting for as the fire grows, individual sprinklers activate and put a clean sheet of water over the entire pane. So this is a good perspective. Class A fire, which is your common combustibles, has temperatures upwards of 540 degrees Celsius. All right? So that fire grows, and then the municipal water department, 15 degrees Celsius water. That's a big range for thermal expansion. And what you notice is a lot of these windows fail. So I have some videos I'm going to show you. What we did with this sprinkler is we used the common time temperature curve that you would use for your standard fire-rated glazing units. Inside that oven, we utilize these sprinklers. Then what happens is over a period of time, we make sure that there's no thermal failure on the glazing unit. And this is fairly standard glazing unit. At the end of the test, they take a hose stream and they spray it to see if that thermal shock happens. And I have 2 videos there of how our sprinklers will work further on. But just like the other sprinklers we talked about, there's plenty of different flavors of these, all right? Plenty of different shapes and sizes. So you see here vertical sidewall and horizontal sidewall, and this is all based on your construction type and what will fit that mark. So here's a couple examples. These are actual installations. The one picture to the left is MIT in Boston, so Massachusetts Institute of Technology. And what you're seeing here is a separation of a corridor to a clean room. So someplace that's most likely being MIT for medical equipment. They want to keep the dust and whatnot out. We're utilizing the window sprinkler here. You can also utilize a horizontal sidewall, but one big thing with the horizontal sidewall is the installation requirements aren't the prettiest. All right, so this was kind of an afterthought. They realized they needed some sort of fire-rated glazing in this picture. And you can see the pipe network here. And fire would grow there, and we aimed to put a clean sheet of water over the entire surface there. So here's our videos. What this is we have a fire about 2 inches away from our glazing unit itself. I'd like to have this person's job. It looks like fun. Okay, our sprinklers are activated. You can see that the water is flowing down the glazing unit now. It looks like we have a clean sheet of water here. And after time, the fire is extinguished. I know I told you that our sprinklers control, but it just shows you how effective sprinklers are, really. So pretty impressive video to see. The next video is going to be the hose stream test. After that time temperature curve, we introduce the hose stream to the window to see if there's going to be any failure due to thermal shock. So fairly realistic test. During a fire scenario, that fire could be burning for a decent period of time. Then fire service comes in and operates their hoses. The last thing you want to do is penetrate that wall because you could have radiant heat spread through the structure itself. I will say I've done some fire service training. Whoever trained this person here must be a little bit crazy because that hose is going all over the place. But it is a test to ensure that throughout the entire glazing unit we don't get failure. One thing on the first video, the last video I showed you, just to point out, and I had alluded to it, is the control of fire versus suppression of fire. So our sprinklers are designed to control fire, and in this scenario, they're designed to protect the exposures of that fire. But if it's used and designed properly, inherently you'll get a better fire effect, or that fire will be smaller when it comes time to extinguish the fire. So what you utilize in the design here, since it is performance-based design, you have to go back to the manufacturer's guidelines because we did the testing, we have the test report. You'll notice there's an engineering evaluation report as well that just explains that time temperature curve as you're starting to utilize it again through egress corridors when you have glazing units in buildings. There's an email there that if you are interested in having these test results, feel free to email. Since it's performance-based design and outside the scope of our standard practices, there are some unique installation requirements. Things like spacing, the types of glazing that you could utilize it on are all limited based on our testing. So one thing you'll notice here, this is just the installation of the horizontal sidewall. You have to maintain a space of 12.7 millimeters to 101.6 millimeters. That space must be maintained. You also notice that it's on a flat ceiling. It's got to be typically an unobstructed ceiling as well. If you were to hide this thing inside of there, what you'll notice is the heat response won't be good. So it has to be a flat ceiling. That way the fire grows. It's able to ensure that our thermal element operates. Same with the our vertical sidewall here. One big thing with this testing is you have to maintain combustibles 2 inches or 50.8 millimeters off the face of the window. We do not want our heat right at that window. So you'll notice that it requires some other installation of the structure itself called a pony wall. And the reason for that is because we didn't test it with the fire on top of the glazing, so we can't back it with our test reports. This is a little sneak peek. We noticed that people don't typically like looks of sprinklers, so we also have a concealed option that should be out on the market fairly soon. So what this does is eliminate the visual looks, and it also eliminates the need to have to hide it with pockets in the ceiling and whatnot. So very similar requirements, very neat product. A lot of people waiting for this product to get out on the market. It's mind-blowing to me how many people don't like the looks of sprinklers. You'll also notice here that the minimum spacing of 1.83 meters up to 2.45 meters is very important. You're not going to see that in your standard in an FPA 13. If you want to space it closer, we require that you put baffles in. That way it blocks the spray pattern, because if one sprinkler operates and it wets another sprinkler before it operates, the other sprinkler will never operate. We call that cold soldering. So these baffles are very important as well as you go through the design criteria. So one thing they're not listed for, and it kind of makes sense, is horizontal mullions. So if you have a sheet of glass and some sort of structural or aesthetic mullion in the horizontal direction, what that doesn't allow is for that clean sheet of water to flow down the entire sheet, so you can't utilize it for that either. So to get a true equivalent 2-hour rating, it's required to have a sprinkler on both sides, which makes sense, because if I start a fire on one side, the sprinkler behind that glazing unit is absolutely useless, so it's required for both sides. We've seen allowances that allow for you, and this is per the authority having jurisdiction, which I know is kind of a touchy subject here, but whoever's designing this, sometimes there's an allowance to only utilize a sprinkler on one side. So if you think of a glass atrium, 10-story building, if we had a fire on the 5th floor, we've got bigger issues than putting a sprinkler on that glazing unit. So if you protect the room, per se, on the outer side of that atrium and use one sprinkler, sometimes there are allowances. But per the standard, you need a window sprinkler on both sides of the glazing units. So single pane glazing, it's a very specific type, insulated, non-operable glazing, very important. If you have doors and windows that you can open and close, the sprinkler hasn't been tested for that, so it would be required to use fire-rated glazing there and protects the surrounding glazing with our window sprinkler. Sloped glazing is not allowed. You ever take water and put it on a sloped piece of glass or something like that, especially on the inside, it's not going to create that nice clean sheet of glass. Glass doors are operable. Have to use fire-rated doors and protect the space surrounding it with the window sprinkler, operable windows, and last but not least, which we've already talked about, is the horizontal mullions. You're unable to use it. So it's kind of interesting when you release a product like this, because everybody wants one solution that fits everything. So it's really important that you contact us or you look at the manufacturer's guidelines during installation and design for this. And this is really a plug for all manufacturers' technical data sheets due to the fact that it's our information, our test protocol, and if it doesn't apply to your application, we'll tell you that it's probably not the best design scheme. So it's not an answer for everything, but it is a good tool to have in the toolbox come time for designing utilizing this sprinkler head. So the pony wall, and again, what this was to do is keep combustibles directly off the glazing units. And that's really all it is a small wall about knee-high that is spaced far enough away that combustibles can't be pushed right up against it. And our testing was with the firelight glazing, but here's an example of a pony wall. Small wall here that just keeps everything off of it. If allowed, you could utilize a different type of construction rather than gypsum board or drywall. And I'll show you an example there as well. Same concept with our horizontal sidewall. We just want to make sure that the combustibles are not directly on there. And here's an example. It's kind of hard to see, but it's almost a pipe. Whoever accepted this design allowed for very similar to things that you may see at supermarkets. That way the cart doesn't hit shelving and whatnot. Just a very small pipe around it has been allowed in this circumstance for this pony wall. So there are very definitive requirements for this pony wall, but it is kind of flexible depending on what your scenario is. So I kind of challenge you as you move forward through either your career or through these different design phases and the growth of the fire protection industry here in Brazil to take a look at these other options, because just because we're used to one direction and one protection scheme doesn't necessarily mean that it's the most effective and the most efficient. So I leave that with you, and if you have any questions, feel free to contact me. My contact information will be up here, and we'll also have a moment here for questions.